Metallic bonding refers to chemical bonding in which the nuclei of the metal atoms are held together in a lattice and are surrounded by a sea of electrons. Metals form a lattice, which might remind you of an ionic lattice. In an ionic lattice, we have positive and negative ions arranged in a regular pattern. These ions are fixed in place, creating a rigid structure. They can't move around, which is why ionic compounds are usually poor conductors of electricity when solid. In a metallic lattice, the structure is made up of the positive nuclei of the metal atoms. These nuclei are surrounded by a sea of delocalized electrons. The positive nuclei form a rigid structure, much like the ions in an ionic lattice. However, the key difference here is the delocalized electrons. These electrons don't belong to any particular nucleus and are free to move throughout the entire structure. So, while the positive nuclei are held in place, the electrons are free to move around. This freedom of movement is what gives metals their unique properties, particularly their electrical conductivity. Metals are good conductors of heat and electricity. When you apply an electric field to a metal, the free electrons start to move. This movement of electrons is called electrical current. Since these electrons can move easily, metals are great at conducting electricity. Additionally, the free movement of electrons also helps metals conduct heat efficiently, making them excellent conductors of heat as well. Metals generally have high melting and boiling points. This is because the metallic bonds between the positive nuclei and the sea of electrons are very strong, requiring a lot of energy to break. Metals are malleable and ductile. Malleability is the ability of a metal to be hammered or rolled into thin sheets. Ductility is the ability to be drawn into wires. Both of these properties are due to the layers of atoms in a metal lattice being able to slide over each other without breaking the metallic bond. The delocalized electrons allow the atoms to move past one another while still maintaining the metallic bond, which is why metals can be shaped and stretched so easily. That's all for today on metallic bonding. Thanks for watching. If you enjoyed this lesson, please like the video and subscribe to our channel for more chemistry content. We look forward to seeing you back in the science class soon.